Alright guys, let's go over some basic wiring for motor control. In this video we're going to do the 2-wire and the 3-wire control for contactors for a 3-phase motor control. So the first thing we're going to do is the 2-wire control. With this guy we're going to find that there is obviously 2 wires in the pipe and possibly a bonding conductor. With this one of the terms that corresponds to the 2-wire control is low voltage release. So the reason why this guy is called low voltage release is this is often the wiring for a pump or for a fan or HVAC unit or something, where in this case on this diagram we have a float switch that when it closes it turns on the pump. So if this contact was closed, so it was calling for the pump to be on, and all of a sudden we lost power, well then the coil would kick out and then we would lose power to the motor. So these 3 contacts would open and we would lose power to the motor. Once power was restored to the circuit and that normally closed contact on the float switch was still being maintained closed, well then we have power going to the coil. That will re-energize those contacts, closing them and allowing current to go to the 3-phase motor. So 2-wire control is for if you lose power, the motor is going to kick off. When power is restored, all that's happened is that the coil has just released. Once the power is restored, the coil will turn back on, energize and close those contacts and re-energize the 3-phase motor. If we look at the 3-wire control, it's going to be called low voltage protection, in that you're going to have to press a push button or turn on a key switch in order for that motor to turn back on. But why would you want to run around the whole building trying to turn on all the pumps and all of HVAC units on a loss of power? Doesn't make sense. So we need to have something like a 2-wire control so that when power is lost, the motor turns off, and when the power goes back onto the building, everything turns back on that is fed by a circuit like this. Now we're going to take this circuit right here, we're going to bring it over to the next page, and then we're going to do some wiring based off of there. So what we'll do is we'll draw in that diagram below. So this guy is a normally open float switch, and normally open because gravity would act on that to pull it down. Now we can do the float switch first. That's better practice to do the overload as the first thing in your circuit. Now the overload is a normally closed contact, right? And that guy is right here. It's right beside the heaters, 1, 2, 3 heaters, and they're just there to protect the conductors of the 3-phase motor. All the current goes through these heaters, heats them up, and then if any of them heat up to a certain point, this contact is going to open, and if this contact opens, then we no longer have power to our coil. So we'll draw in our coil here, and line 2 or neutral, depending on which voltage that we're working with. If this was 120 volts as the source for our controls, this would be line 1, this would be neutral. If we had 208 or 600, then we were grabbing the power from any 2 line conductors. So this would be line 1, and this would be line 2. So that's what we'll do for this diagram here. Now we'll label out each of these conductors. 1, 2 is the return. We go through that overload contact, so we have a new wire number. Then we go through another component being the normally open float switch. So then we got 4 wires here. Okay, so let's take that diagram and now wire up our wiring diagram above. Looks like first thing we're doing is we're going to the overload. So we'll pick that up off of line 1. And this guy's done. Good practice to kind of check off each wire as you put it in, then you don't miss anything. From there, we're going out to the field to the normally open contact for a float switch. So we're coming over here, picking up the overload. Beauty, that guy's done. Okay, if we wanted to put our conductors here, this is 1, 1. This conductor would be labeled 3, and this guy is labeled 3 as well. Okay, from there we're now going to the coil. So we're going to pick up our coil here from our normally open float switch. See if I can erase this. No, it takes out the whole thing. Sorry about that. This guy comes down. Picks that guy up. Beauty. There is our coil. This is done. Last thing we need to do in this case is go to line 2. Over these guys. Pick up line 2. And excellent. We're done. That's all it is. Okay. The conductor here would be 4. This guy would be 4. Right? And then our return is going to be labeled conductor number 2. Inside the pipe, how many wires have we got? Well, it's 2-wire control. So we're going to have 2 conductors in the pipe. And a bond wire. Okay, 2-wire has 2 conductors in the pipe. 3-wire is going to have 3 conductors in the pipe. Okay. Next one, 3-wire control. We've got our ladder diagram. We've got our wiring diagram. And we've got a pictorial of what's going on here. Okay, so what we're going to do is we're going to take this diagram here for the ladder diagram, transfer it over to the page with the components with the starter here. So here's some, basic diagrams there for the 3-wire control. This one here, it says it's the 3-wire, but they don't have the holding contact. The 3-wire makes use of the holding contact across the start there. Okay, again, another diagram of the 3-wire control. I like to put the stop first and then the start, but in this case they've put the start and then the stop push button. Okay, and then they've actually got their overload in a funky place in between the motor contactor and their push buttons. It doesn't really matter, it's in series with the coil, but it's usually the first component in the circuit. Okay, let's take a look at this one now. So we'll do our diagram for the 3-wire up here. Line 1. We're going to do our stop push button here. Stop is the normally closed. Then we're going to do our start. Start is the normally open. Then we're going to go to the coil. I forgot the overload, so let's drop the overload in there. Now all the textbooks have this guy at the end. Right, so our coil is there, or we could put in an M there for motor contactor, and then we've got line 2. So yeah, all the textbooks have the overload over here, but by rights the overload should be the first thing in the circuit. This, as drawn, is still a 2-wire control. The key to making this guy a 3-wire control is to put that holding contact across the normally open switch. Now, if we didn't have that overload there, then labeling this out, we could just go 1, 2, 3, right? So normally this guy right here is labeled 2 and 3 on the starter. The reason for that is that if that overload wasn't there as the first component in the circuit, then sequentially labeling all the conductors, we've got conductor 1, conductor 2, conductor 3. Then a normally open contact looks like it's labeled with conductors 2 and 3, and that is why these are usually labeled 2 and 3 on the starter. We're going to keep our number 2 as the return, so that guy is going to go there. And then sequentially, this would be our first conductor. 2 is the return, so this is wire number 3, number 4, number 5, and this guy is the same conductor. Now, to simplify things as well, that's, a cleaner diagram, but we can go like this as well. And then you can see that on either side of that push button, it looks like there's going to be 2 conductors there. Okay, let's use that to now wire up all the components that are on the page here. So the first thing we got is we're going to the overload. The overload is this normally closed contact here. So we'll pick off line 1. Over to the overload. Okay, this guy is done. Next thing we need to do is go to the normally closed switch. On this diagram, we're coming in on the left, so we're going to come in on the left over on this component as well. Excellent. Okay, so we've come into the left-hand side of the stop push button. From there, it looks like we go to the left-hand side of the start push button. Again, we could just go like this, but then we're going to get confused later on when we're doing troubleshooting. So try and keep the same convention. Whatever's coming in on the left-hand side is the in. On the right-hand side is the out of each of the switches. From there, we're going to go to the coil. So we're going to pick up our coil there. That takes care of this guy. If we're going to throw on our conductor numbers, this is 1, right? This is 3. Then from there to the start switch was 4. This is conductor number 5. Right? And then from there, we just have to pick off line 2. Excellent. So that's going to be wire number 2. Right on. The only thing we need now is the normally open contact across the normally open push button. So we need to have one side going, it looks like this side of that contact goes to this side of that push button. So we can go there, or we can go right to that side, the left-hand side of the coil. Well, essentially that is this guy right here. So we can connect in the normally open contact to that same point that we're feeding the coil. It's the same piece of wire. Why would you bring another conductor all the way out to the switch when you can just do 6 or 8 inches of conductor and pick up on your A1 on the coil? Again, this is usually labeled A1 and this guy is labeled A2. Excellent. So we have picked this guy off. Now we've got to have a conductor going from the left-hand side of the push button over to the other side of the contact. So we're going to pick off this guy on the left-hand side, come over, and pick up the other side of our normally open contact. This is a 3-wire control. So looking at the conductors in the pipe, there are 3 conductors in the pipe, and possibly a bond wire, depending on which type of conduit you use to wire to go from the stop-start push-button station over to the starter. All of these components are within the starter, so here we've drawn the fuse disconnect here. Well, not the fuse disconnect, but just the disconnect. Then we've got our 3 contacts that correspond to this coil. These contacts are all horsepower rated. This one is rated for less current in that it's just in our controls, so it has a lot less current being applied to it. Current is coming down, easy now. Current is coming down to the overloads, right, and then going to our 3-phase motor. Okay, if we're taking a look at the components here, then these 2 on a NEMA starter are the coil. And again, remember I said that those 2 sides of the normally open contact are often labeled 2 and 3. Well, there they are right there, 2 and 3. The normally open contact is just tucked in at the back of your NEMA starter. Okay, your main motor contacts are here. The current will flow through the heaters. At that point, the heaters are not placed in there, but it will go through the overload heaters. And we have line 1 going to T1, line 2 going to T2, line 3 going to T3. And the labels for these guys, if they are not there, would be A1 and A2 for a coil. Okay, so the 2-wire provided us with low voltage release, and this guy provides us with low voltage protection. In this case, if you have a loss of power, then this coil is going to kick out, which will open all 3 of these contacts, which stops current flowing to the motor. When power is restored to the building, current does not automatically flow to this 3-phase motor, because the current, you can see, will be blocked by this normally open contact and by this normally open switch here. So you have to actually press the push button in order for the coil to be re-energized, for these contacts to close, and for current to go to the motor. So in that case, it provides a protection when you have a brownout or when you've had loss of power, in that you have to press the push button in order for the motor to turn back on.